So this is question 4, 2011 Higher Paper 2. Question asks us to find total shaded area, this part plus this part. Diagram gives a curve, cubic and a straight line, straight curve, and their formula. So before we start, the result we're going to use, find the area between two curves. There's the x-axis. From there to there, so let's call that x equals a, that's x equals b. And this top curve has some formula, y equals f of x. And this bottom curve has some formula, y equals g of x. And to find this area between the two curves, we use the result that the area will be the integral from a to b, top curve, f of x, minus bottom curve, g of x. Top minus bottom, from a to b, from there to there, top minus bottom. And that gives us that area. So that's the result we're going to use, and we'll see how to apply it in this case. So we'll split this up into two sections. There's area 1 and there's area 2. And in this part, the top curve, you'll notice, is the cubic one, this one. And the bottom curve is the straight line or linear curve, 2x plus 4. When we get to this area, the top curve is the linear curve, 2x plus 4, and the bottom one in this case is the cubic, this expression here. So they've been swapped round. So let's first of all find area 1. Let's set up the integral. So integral from minus 2 to 0. There's your x equals minus 2, and there's your x equals 0. So left to right, minus 2, bottom to top, minus 2, 0. So it's integral from minus 2 to 0 of top curve, which is this, x cubed minus x squared minus 4x plus 4. That's your top curve, minus bottom curve, which is 2x plus 4. And it's the whole of 2x plus 4. I'll put both of them in brackets. Brackets aren't needed in the first one. It's just to be clearer. So we're not going to integrate just now. We need to simplify this expression that's between the integral brackets, if you like, this integral sign and the dx. So all this expression in here needs simplified. So again, we'll write integral from minus 2 to 0, and we'll have an x cubed minus x squared minus 4x plus 4 minus the 2x minus the 4. So it's minus the whole of 2x plus 4, not just the 2x is being subtracted. So there we go, with a slight simplification before we integrate. It's always easier to simplify first and then integrate. So there's no other x cubed term in there, so there's an x cubed term sitting there, minus x squared, no other x squared term. Now the x terms, there's a minus 4x and a minus 2x, which gives us a minus 6x. And the constants 4 and minus 4, they cancel. and there's close your integral brackets, integral sign and the dx. There's a pair. Consider them as a bracket, and anything that goes in between them needs integrated. So there we go. We're ready for integration. Now remember the integral, the basic integral rule of a power of x is that the power increases by 1 and then you divide by the new power. And when we don't need a constant plus the c, we don't need that when we've got numbers here. And remember, the results of doing this get put in square brackets. So x cubed becomes x to the 4 divided by 4 minus x squared becomes x cubed divided by 3, and the minus 6 just sits there while the x to the 1 becomes x to the 2 over 2. Close your square brackets, retain the minus 2 and the 0 by attaching them at the end of the bracket. This means that we are going to plug in 0 and plug in minus 2 into this resulting expression. There is a very small simplification required. X to the 4 over 4 is okay, as is minus x cubed over 3, but the 2 and the 6 on the top, 2 on the bottom, will divide the top and bottom of this fraction by 2, so we get minus 3x squared over 1, which is just 3x squared. Close the brackets again, minus 2 from minus 2 to 0. So, to do this, to evaluate this, to find the number that results from this, we've got this expression with x equals 0 in it, minus the same expression with x equals minus 2. So this bit's the x equals 0 goes in there, and this bit, the x equals minus 2, goes in there. So let's start. Putting 0 in here, 0 to the 4 over 4 minus 0 cubed over 3 minus 3 times 0 squared. All of that will come to 0. Nothing divided by 4 minus nothing divided by 3 minus 3 times nothing. That all comes to 0 in a wee minute. Now we're putting minus 2 in, which is a slightly more substantial calculation. So we've got minus 2 to the power 4, 4 of these multiplied together, all over 4, minus 2 cubed. So 3 minus 2 is all multiplied together over 3, minus 3 times minus 2 squared. So let's try and do our calculation. As we said, that all comes to to 0, minus negative 2 times negative 2 times negative 2 times negative 2. 4 of them multiplied together. There's 4 negatives, so the result's positive. 2 2's are 4, times 2 is 8, times 2 is 16. So 16 divided by 4. Minus 3 of these negative 2's multiplied. There's an odd number of negatives, so the result will be negative. And 2 2's are 4, times 2 is 8. So there's a minus 8 for the minus 2 cubed over 3. Minus negative 2 squared, positive 4. Negative 2 times negative 2 is positive 4. Times the 3 is 12. So it's minus 12. So we are progressing with this. Let's continue. Let's put the answer in here. So minus, now 16 over 4 is 4, so it's minus the 4. Minus 8 thirds, minus 8 over 3 is minus 8 thirds, subtracting that be positive 8 thirds, but with this minus outside it will be minus 8 thirds. And then subtracting minus 12 plus 12. 12 minus 4 is 8, so we've got 8 minus the 8 thirds. Now how many thirds is 8? 24 thirds. So we have 24 thirds minus 8 thirds. So 24 of them minus 8 of them would end up as 16 thirds. So we have 16 thirds. And that does give us the area 1. So area 1 is equal to 16 over 3 units squared. Let's move on now to area 2. Let's set up the integral. So this time integral from 0 to 3. Top curve this time is 2x plus 4 minus bottom curve this time, bottom curve this time is the cubic expression. So minus x cubed minus x squared minus 4x plus 4. Close the integrating brackets. This is actually this subtraction but the other way around. If you compare, for instance, 8 minus 4, which gives you 4, with 4 minus 8, it gives you negative 4. That would imply that what we're going to get once it's all simplified is the same as this, but with the opposite sign. So that would imply that this would be negative, this would be positive, and this would be positive. And that would therefore carry over to this integration, where all these signs are the opposite of what they are. So this final result here can be used provided we change all the signs, because we get the negative of what we had before. That's the only difference between this expression and this expression. The signs have changed. So let's just write minus x to the 4 over 4 plus x cubed over 3 plus 3x squared. This time the limits are different. We're going from 0 to, there's x equals 3. 0 to 3. 0 to 3. So to work this out, we're going to substitute 3 in there and subtract what we get when we substitute 0 into there. So let's do the 3. That's minus 3 to the power 4 over 4 plus 3 cubed over 3 plus 3 times 3 squared minus, and we know this is all going to come to 0, but if you make mistakes, at least the examiner knows that you knew what you were doing before you made the mistake. You might get a mark for it. So 3 to the power 4, 4 3's all multiplied together. 3 times 3 times 3 times 3, 3 3's are 9, 3 9's are 27. Well, let's do it this way. 3 times 3 is 9, 3 times 3 is 9, 9 9's are 81. So that would be minus 81 over 4 plus 3 cubed, 3 3's are 9, times another 3 is 27. So that's 27 over 3. Mind you, 3 goes into 27, one of the 3's cancelled, and you're left with 9. So we should have spotted that. One of the 3's on the top and the bottom cancel, and you're left with 3 squared, which gives you the 9. Plus 3 times 3 squared, 3 times 9, 27. So we've got a 27 in there. Now 9 plus 27 is 36. So we've got a 36 minus 81 quarters. So I think possibly we should produce quarters for the 36 and multiply 36 by 4. 4 6 is 24, 3 4 is 12, 13 14 is 144 quarters minus 81 quarters. quarters, which gives us, well, 1 from 4 is 3, 8, that's 63 quarters. And that's units squared, because that actually does give us this area too. So how are we getting on? We've got two numbers so far, area 1, area 2. We're asked to find the total area. So the total area will just be the sum of these two, the sum of 16/3 plus 63 quarters. 12ths springs to mind, times 4 times 4, so that's 64 12ths, times 3 times 3, 189 12ths, and we need to add these together, so 253 12ths units squared. That's our final answer. Wonderful question.